Well, aloha everyone. Today we're going to talk about the types of magnetism. So here I have a paper clip that I put onto a little piece of foam and I placed in this pool of water. And the first type of magnetism that you need to know about is called ferromagnetism. Ferro coming from the Latin for iron, because iron is one of the types of elements that exhibits this magnetism. In fact, it's the one we're most familiar with. So I have a magnet here, and I have this paperclip that's mostly made out of iron. Ferromagnetic materials react strongly to external magnetic fields, and they're attracted to them. So it's no surprise that when I bring this magnet fairly close to this paperclip, you can see it is strongly attracted to this magnet. Nickel is also a ferromagnetic material. So I've replaced the paperclip here with a nickel. And even though it doesn't react as strongly as the iron does, you can see when I bring this magnet close to the nickel, I'm able to pull this nickel across the water. It doesn't stick nearly as strong as the paperclip does, but you can see that this nickel is clearly attracted to the magnet. The second type of natural magnetism we'll encounter is called paramagnetism. Aluminum is paramagnetic, along with several other elements, and that means it responds to magnetic fields, but not nearly as strongly as a ferromagnetic material would. So here I have a piece of aluminum that I placed on this floating piece of foam, and I'm going to bring the magnet near it, and you can see that it is attracted to the magnet, though not nearly as strongly as either the iron or the nickel. In fact, an important thing to remember is that there are three ferromagnetic elements. Those are iron, cobalt, and nickel. Aluminum is what we call paramagnetic, in that it's not attracted strongly to a magnet, but it is attracted very slightly. You have to watch very carefully for this, but I can pull this around using the magnet. The final type of natural magnetism that we need to know about is called diamagnetism. Now, it turns out that both copper and zinc are diamagnetic. And looking at this, we see we have a modern penny. Pennies made since about 1983 are mostly zinc with a little bit of copper in them, only a little bit. So because of that, they're mostly zinc, but both elements are diamagnetic. And so I'm going to take my magnet and I'm going to place it near this penny, and we'll see the difference. Instead of attracting it, you might be able to see that this is repelling it. Diamagnetic elements and diamagnetic molecules in general are going to be, instead of attracted to the magnet, they're going to be repelled. In most places in the world, there's quite a bit of iron in the soil. So here I have some dirt that I picked up from my backyard, and I have a magnet. And if I take this magnet and just run it through the dirt a little bit around, you will see that some of the dirt sticks to the magnet. This is a mineral that naturally occurs in the dirt that is called magnetite. And this mineral is ferromagnetic. It responds strongly to magnetic fields, and it builds up. So here, I've separated a little bit of the magnetite from the rest of the dirt. And you can see just how strongly it responds to a magnetic field. We can actually build up quite a bit of magnetite on these magnets. And so, because of that, and you'll even notice that you get a little bit darker color than most of the dirt was. Sometimes you can even see patterns start to form almost like iron filings. So, because of that, it turns out that most of the world's dirt has ferromagnetic materials in it. However, the question then becomes, if it's ferromagnetic and the Earth has a magnetic field, why isn't all of the dirt magnetic, magnetized into permanent magnets? And the answer is the Earth's magnetic field is not strong enough to create permanent magnets. But there are some naturally occurring magnets that happen because of, that's correct, lightning. So, as a quick recap, we have ferromagnetism, which happens to three elements: iron, cobalt, and nickel. And these things are strongly attracted to magnets. We have paramagnetism, which happens to many other elements, such as aluminum, in which they are weakly attracted. And then finally, we have diamagnetism, in which elements are repelled. The classic examples of this are copper, zinc, and even water is diamagnetic, and so water is actually repelled by magnets. Now, another important thing to note is that just like naturally occurring magnets are created from lightning strikes, all magnetic fields are created by moving charges. So, for instance, if you think about an atom, the classic example, the Bohr model, has the nucleus here and electrons orbiting around that nucleus. Well, we know this isn't quite the case, but if we think about it, those electrons are moving. So in some atoms, the electron might be moving around this way. In another atom, you might have an electron moving around this way. If you have these two things moving oppositely, they would cancel each other's magnetic fields out, and you wouldn't see any large-scale magnetic effects. However, if you could get a whole bunch of atoms to all have their electrons going the same way around an atom, the magnetic field of each of these electrons would build up. And in fact, in iron, cobalt, and nickel, when you create a permanent magnet, this is what you have done. You have aligned the way these electrons are traveling around the magnets. And so having them all traveling in the same way means that you get a magnetic field that you can actually measure. But there's something else that's important here. You will notice all magnetic fields are created by moving charges. The corollary to that is all moving charges create magnetic fields. So that means when you have electrons moving in a conductor, let's say current, all those electrons moving in a conductor are going to create a magnetic field. So in addition to the three types of naturally occurring magnetism that we've seen, there's also another type of magnetism we need to know about, and it's called electromagnetism. Oh. And electromagnetism is created when electrons are moving, or charged particles in general are moving. Now that happens naturally in things like lightning, and lightning produces strong magnetic fields. But it also happens naturally Well, it also happens artificially when humans move electrical charges in current through wires. So it turns out every wire with current moving through it is going to have a magnetic field. In next time's lecture, we're going to talk more in depth about this idea of electromagnetism and about moving charges creating magnetic fields. But the keys to this today are to know the different types of magnetism, the three exclusively naturally occurring ones, and the electromagnetism that occurs when charges are moved, whether naturally by atoms lining up, or things like lightning, or whether it occurs artificially by humans pumping electrical energy through a wire. So that's really all there is to magnetism, at least for the introduction to it. So, mahalo for watching, and we will see you next time.